My name's Tony DeVito. I've been an adjunct here for 18 years or so, 18 or 19 years. Right, most don't last that long. I'm a glutton for punishment, so I just stuck around. But I actually am a graduate in the master's program in environmental occupational health science back in the, I guess, late 80s or something like that. And I came back here and started teaching a few courses in that department. One semester they needed somebody to fill in as a lab instructor in biostatistics. And I did it that semester, and they really needed me to do it the next semester. So I did it then. In both semesters, I hated it. And then by the third semester, it started to grow on me. And then by the fourth semester, I kind of actually liked it. It's pretty interesting stuff. So, so before that, I could never imagine why somebody would become an accountant. But now I understand, like once you start to understand it a little bit better, you see a little bit of the art in it and stuff like that. So our main motivation tonight is, number one, to get to know each other. Number two, to understand what's expected of you in this course and what you can expect from me in this course. Okay, so that's, I think, a pretty good way to start off. Okay, so I got a little bit of a presentation that, a lot of the times I'll be sitting down tonight because I'm using the built-in microphone on my computer, and if I step away too much, my voice is going to fade away. You'll see in the recording that it's going to do that. Okay, so I'm going to be stuck to my computer a little bit more than I want to be tonight. In the future, I'll try and get my wireless mic working so I can move around a little bit better. Okay, so I wanted to get out of the way a little bit so you could see that. Basically, for starters, we're going to be working with certain kind of tools that we're going to need, specifically computer tools, because these days you really need computers to do statistics. I mean, the amount of data that you're usually processing and stuff like that is enormous compared to what you might be looking at a while ago. In 1967, I went to Brooklyn Polytechnic, the Polytechnic Institute of Brooklyn, which is on J Street, across from New York City Community. I don't know what it is now, but it was New York City Community College. And that is what I used to do calculations on in those days. About a year later, some outfit called Wang came out with an electronic calculator, a desktop electronic calculator, which kind of put them out of business. And within about another year or two, then they came out. So the Texas Instrument and a few other companies came out with portable electronic calculators. I think like the TI-19 or something like that. Might have been one of the early ones. But they put the slide rule out of business. I'll bring a slide rule in here one of these days and get a chance to see what one of those things look like. But that's what I was using at the time and this did a lot of stuff. The version I was using actually would do some squares and square roots and stuff like that. So they were pretty impressive mechanical devices. Okay, and that's a slide rule. That's the other thing that we use as an early desktop calculator. One of the things that we used to use to organize data quite extensively was ledgers, right, or what we would call spreadsheets. They were basically, big pieces of paper. If you ever seen Christmas Story, that's what Scrooge's helpers are working on. They're working on like ledgers with columns and rows of numbers and so on and so forth. And they would keep it. Anybody ever do double entry bookkeeping or know anything about double entry bookkeeping? Basically, you have two columns, debits and credits, and you keep track. In other words, if you have to write a check, that's a debit. You write next, on this side of the page, you put your credits and go line by line and so on and so forth. And then at the very end of the page, you add up all the debits, all the credits, you figure out how much you have, you carry it over to the next page, and you start all over again, doing all that kind of stuff, right? So that's the way people would organize data. They'd have name, address, so on and so forth, lists, phone books. People used to carry around like black books with them and stuff with little addresses and phone books. But it was labor intensive. You had to have hard copies and stuff and so on and so forth. And if you made a mistake anywhere in that ledger, you had to go back and deal with that mistake. Well, the reason why double entry bookkeeping was so popular was because you didn't really go back and change that mistake. Just put an asterisk on it, and you put a credit or a debit and explaining why you had to make that adjustment or something like that. So you didn't have to go back and recalculate all that stuff. Now, if you're designing an airplane or you're doing a statistical study, it's a little harder. You can't just go back there and say, oh, I'm gonna nudge this number up a little higher to make up for the number that I put in that was incorrect before. You probably did a lot of operations calculations on that since then. So one of the things that happened was This fellow over here, this fellow over there in that corner, his name is Dan Bricklin. He invented the electronic spreadsheet. I think I have a link to a video. I think they took the video down on YouTube because it's proprietary. But it was invented the first electronic spreadsheet on a computer. That was called VisiCalc. Anybody ever hear of VisiCalc? No, that's because they didn't patent it, right? So back in those days, people were contributing software kind of like to this open source enterprise of people that were interested in these kind of geeky pursuits. So he invented this spreadsheet called VisiCalc, which kind of transformed the landscape for computers. The first computer that it ran on, in fact, became a focal point for a lot of people being interested in computers, especially business people, because this is the kind of thing that they would need, something that would help them work with numbers and help them correct errors and make projections. We're going to see that a spreadsheet is very good at making projections because you can make various whole string of hundreds of calculations and then go back and make one little change and have it automatically recalculate everything and give you, a new output or something like that. So you could make a judgment about whether if you make that change, how it's going to impact what you're going to wind up with. So that made this very popular. The only computer it ran on was the Apple II. And believe it or not, this is what they called back in those days a killer application. Businesses would buy Apple IIs to run this software. So it was really the software that really drove the early growth of the Apple II. Of course, then there were all sorts of other things that made it pretty popular as well. So I'll see if I can get you a look at that. This is what a ledger looks like. They're actually pieces of paper. I used to bring in actual old ledger sheets and stuff like that I had lying around. So the most important thing about this is that it allows you to do mathematical operations. Okay, we're going to play around with it. How many of you guys don't use Excel or another spreadsheet very much? Yeah, there's still some people that are holdouts, right? So I'm gonna kind of introduce it a little bit. I can't spend too much time with it because it's a biostatistics course, not a spreadsheet course. I'm getting over a cold, by the way. But I can certainly introduce it and give you some of the basics, and then you can kind of take off with it. I can probably come up with a bunch of links for easy training and stuff like that. The other thing we use quite a bit in statistics is databases. They have programs that are designed to organize data. Simple one could just be a simple phone book or phone list or something like that, like on your iPhone or on your phone or something like that, right? But more complicated ones can be what they call relational databases, where there are multiple databases and all of the data is interconnected and organized and indexed, so you can look up things in a moment that you normally have to go through a very, very long list to find, right? So databases are another kind of software. The difference there is that a spreadsheet program is a basic, generic, kind of general piece of software that you can use for a lot of different things. Databases, too, you can use them for a lot of different things. Okay, that's one type of software. The other type of software that we're going to be interested in, so I can get to it here, is what they call vertical software. Vertical software is software that you use for a specific purpose. It's designed for that purpose. It doesn't do anything else well but that one purpose. If you work in a medical establishment, there's kind of billing software and stuff like that that's specifically made for that, and you can't really use it for anything else. SPSS is a piece of software that's designed specifically to do statistical calculations. Some of you may have also seen similar programs like SAS. Anybody here use SPSS at work? Anything like that? No? How about SAS? No? Okay, good. You're in the right spot. Okay, so you're gonna learn how to use it. You can add this to your resume. If you get bottom there, I have experience with SPSS. Anybody know what R is? Has anybody worked with R? R is a open source a statistical program. It's kind of a crossover between a statistical program and a computer language, where you can actually type in commands to open files, manipulate data, and so on and so forth. And you can even use it for other purposes other than statistics, but it's mainly designed for statistics. It's open source and it's free. It's a bit harder to use than SPSS is, so we're gonna concentrate on SPSS. but I may occasionally throw in at least a data set for it. So if you get really adventurous, you can download it. It's open source, meaning free. You can download it, install it on your computer. You can play around with it a little bit. So if any of you guys like playing with computers, you might find this pretty interesting. And it's actually really kind of taking over from some of these commercial applications. In fact, we're using an open source textbook, right? You don't have to go out and buy a textbook because a couple of three statisticians specifically have put together a pretty good usable textbook that they have now gone through a third edition on. And that basically the way it works is that you submit corrections, updates, suggestions to them, and then they go back and kind of rework and come up with a new edition. So they have a pretty good version of a textbook at this stage. Saves us a couple of bucks, right? So one of the things we're interested in tonight is starting to get familiar with data and how we're going to work with data. One of the most important things that we have to recognize about data is that there are types of data. And depending on the type of data, we're going to be analyzing that data. We're going to be working with that data in different ways. One type of data is nominal data. That's a name. Okay, hair color, right? Nominal data. Country of origin, right? Country you came from is nominal data. Okay, then another kind of data is numerical data, right? Numerical data is anything that you would measure with a number on a scale. Okay, so weight, BMI, blood pressure, blood sugar, they're all numerical. That's all numerical data. Some of that we kind of split up into slightly different types of numerical data. For instance, one type of numerical data is actually what we would call scalar or a number scale. SPSS happens to call it scalar, right? And that's like something that has a range or a scale or something like that. So you have a continuous scale where the units are meaningful, like blood pressure of 50 is half the pressure of blood pressure of 100, something like that. Height of 30 inches is half of height of 60 inches. So numerical data makes sense in one type is scalar. Another type is discrete. Okay, and in discrete data, we're working usually with integers. Like for instance, if I asked you how many siblings you have, and you said you would answer with a whole number, presumably less than 100. So you'd say 2 or 7 or whatever, right? So that's typically called discrete numerical data. Now, probably as we go forward on homework, a couple other places, you'll see we'll ask you what kind of data this is, and one of the choices might be discrete, numerical. I'm not really that concerned about that. If it's numerical, it's numerical. On the other hand, sometimes we'll use numbers to represent categorical data. So for instance, if I say that male is represented by the number 1 and female is represented by the number 2, those 1s and 2s now become nominal data or categorical data. Yet we use the term nominal or categorical interchangeably, category or a name. So now 1 and 2 represent male and female. Anybody have any idea why I might want to even bother doing that? Using 1 or 2 instead of just putting in male or female? A lot easier, right? Put a 1, then type in male or female, because somebody's going to have to put all this data in. And since you guys are the lowest guys on the totem pole, you're just coming out of school when you graduate. This could be you, right? So that's one problem. The other problem is that as far as computers concerned, if you type male, M-A-L-E, and male, M-A-I-L, they're two different things as far as the computer is concerned. If you type it with a capital letter and a lowercase letter, two different things. So it's just easier and more accurate to use numbers to represent that. They become basically nominal data anyway. The other kind of data that we often work with, which could be nominal, could be categorical, more like kind of a crossover between, it's called ordinal. Okay, and that is data that looks kind of nominal. For instance, words, poor, fair, good, excellent, right? Those are words. Normally you would call those categorical or nominal data. The only problem is those particular names, they have a meaning relative one to the other. So we would say that poor is less than fair, fair is less than good, good is less than excellent, right? So that kind of a categorical data is called ordinal data, and that's handled in an entirely different way that you might handle categorical data basically. So if you have a situation like that, I'll give you anybody No one that, like, if you work in a hospital or something like that, a doctor's office, that you use all the time, an ordinal scale. Something where you're asking, the other characteristic of an ordinal scale is that one person's value for that, good, poor, or fair, is different than another person's value. And the difference between fair and good might be different for each person, the difference between good and excellent. In other words, I mean, that may not be a way to really categorize them, but you can categorize one relative to the other. So what's another scale where you might get that in the hospital? You walk into an emergency room and you tell the doctor you're in pain. What might he ask you? What level of pain? What night? From 0 to 10. How much is that? That's an ordinal scale, right? Because your 3 could be somebody else's 6. Your 6 might not mean twice as much as your 3, and so on and so forth. Okay, ordinal data. Okay, another way of talking about numerical data is calling it continuous or scalar. Okay, in other words, it's on a continuous scale. But again, these are words, but these words are important because there's different ways. We're going to use different ways to analyze numerical data, categorical data, and ordinal data. As we move forward, it's important that we recognize that. Okay, we're going to be working with population data, and we're going to be working with sample data. So what's the difference? Well, population data obviously is the data that represents everybody. Like, for instance, if I want the average weight of people in this population, I'd have to measure every person in that population. When I'm dealing with a sample from that population, and I randomly select 100 people from a population and calculate their average weight, we would still call that the mean weight. We call that a mean weight also, but in that case, we're dealing with the mean weight of the sample versus the mean weight of the population. In statistics, typically, when we're talking about that, we're using Greek letters to represent these parameters that are associated with population, and we're using Arabic or English letters to represent our results the same results for a sample. Okay, so mean, sigmas represent something called standard deviation. We're going to get to that, and so on and so forth. So we'll look at that a little bit closer. But you see, if we use Greek letters, it's population. If we use our own notation, it's going to be a sample that we're talking about. Now, do we ever really know the population mean for the most part? Right? It doesn't come up very much because we have to sample. You'd have to get information for every person in that population, right? For average BMI for people in New York. Well, that'd be impossible to measure. You'd have to go and weigh and measure the height of every person in New York. So we don't often see that. And can anybody think of one place where we see population statistics instead of statistics based on samples? What's that? I'm sorry. Yeah, census. Once every 10 years, we have to take a census in this country, right? So you actually go out, you fill out a form and send it in. They send people out. They have an outreach program. If you don't send it in, they'll knock on your door and so on and so forth, try and get the information and so on and so forth. Well, let me ask you something. Doesn't it make, when they do that, when they count people individually, is that perfectly accurate also? No. So what happens in New York City where we have a large population of, say, of undocumented aliens, what happens there? What happens in a situation like that? They're not going to send in census forms. The only way to find them is to go out and try and count them, right? And they're going to avoid counts, right? Especially now. They're particularly concerned now. So we likely will undercount them. There are ways to adjust for that. If we know we can go out, we can take a sample, and we examine an area of the city, several areas of the city, and we figure out that, we're undercounting this population in the Bronx typically by about 9%. Maybe we should adjust for that. Anybody know why they don't adjust for it? What do you think? Where is it, what law says that we have to take a census every 10 years? Anybody know where that came up? It's in the Constitution. That's how the House of Representatives and the electors for president, that's how they're distributed, based on population, based on the census every 10 years, right? And in order to change something in the Constitution, what do you need? You need a constitutional amendment. When's the last time they passed the constitutional amendment? Not recently, right? Not a lot of agreement on that kind of stuff these days, right? So that's the problem. We're stuck with that actual physical count, even though we know that in a lot of ways we can predict what ways that is wrong. So that's the difference between a sample and a population. We're almost always going to be dealing with samples, and we're using those samples to predict what the population is. Right? So we're really interested in the population mean, the average blood pressure of the entire population, the average blood pressure of everyone that would take that drug in the future. Not so much the ones in the sample in our study and stuff like that, but we want our study to help us to predict what will happen when it goes out into the entire population. One of the things we're going to learn about in the first few sessions that we have here is how to summarize and organize data. We're going to take advantage of graphics. Graphics is a great way to demonstrate what a lot of this information looks like. So for instance, this is a bar chart. Now, bar chart is usually used for, anybody want to guess what kind of data? Yeah, frequency, yes, but it's categorical data, right? Nominal or categorical data, names. Like this one is, oh, by the way, this is on Black, I don't know, I didn't mention it, but this presentation is on Blackboard as a PDF file. So you could actually, if you want to look at your screens instead of like craning around me to try and see what's behind me, you can actually do that as well. So let's see, we've got different hair color, red, brown, blonde, black. That's the number of people in that sample that have that hair color. That's a bar chart. Okay, you'll notice that the bars are separated, right? That's because they're different things, right? One's red, one's black, one's blue, and so on. Okay, so now we have other kinds of bar charts, right? There's bar chart. Okay, now this one is a whiskey bar chart. Candy, I forgot I had these on here. Candy bar chart, and of course the ubiquitous sushi bar chart. So, at any rate, this is not a bar chart. This is called a histogram. Okay, and in a histogram, what we're doing is we're taking numerical data and we're summarizing it in categories. So here, what we have is that we have a certain range of, let's say, heights from 114.5 inches to 145 inches to 155, 165, and so on. So anyone that's 144 inches is going to be in here. Anyone that's 142 inches is going to be in here. The minute they cross over into 145 inches, they're going to be into the next box. So this is really continuous. Someone's always going to be in one of these boxes, right? And they're going to cross over one to the other. So these are connected because there is no gap between them. There's not going to be, unless there's just no people in one of these bars completely, there is no gap between them. So the difference between a bar chart is that we're summarizing data that's nominal or categorical data. A histogram, we're summarizing data, the distribution of data that's associated with a numerical variable. So right away, we have a difference in the way that we would display this data. Okay, what's that, a histogram or a bar chart, male and female? Bar chart, right? The categorical data and bar chart. This is the birth weight of 32 lambs. Histogram, right, exactly. So there we go. Now, another very useful chart that we use to demonstrate the middle and the variability of data, numerical data particularly, is a box plot. Okay, and the way that this works, I don't know how well you can see it from there, but it's a little bit better if you have it on your screen. But here, what we're looking at is we're looking at a range. There's a little feather here, a little line here, a thin line here, and a thin vertical line going through here. So this one at the bottom is the lowest value. This one at the top, this is, I guess, what is this? This is diameter of different trees, I guess, right? And I guess in full sunlight and in part sunlight. So this one black maple, this one sugar maple, that's one red maple, and so on and so forth. So the black maples in part sunlight, we can see that the smallest diameter is down here. Biggest diameter is up here. So all of the values are between those two numbers. Okay, I can carry over here and see what the heights are, right? The middle section here that's colored in is the interquartile range. The deal here is that's the minimum. This is the 25th percentile, the bottom of that box. That means that 25% of the trees have a height between here and that little feather at the bottom. Okay. This is the 75th percentile. That means that 75% of the trees are below this. So this would represent the 25th percentile to the 75th percentile, the middle 50% of the thickness of the trees. Okay, and then the ones above here are the upper 25%, the upper quartile. Right, so these are quartiles here. So it's a really nice way of examining, seeing what the variability is, and seeing where the middle is. A real box plot, you'll also see another bar in here, which will represent the median, the middle value, which is the 50th percentile. 50% of the people below it, or trees below it, and 50% of the trees above it. Okay, so what can we see here? See, the variability among the ones that are in full sunlight is much less than the ones that are in part sunlight. We can see that the average value for the red maples, the diameter red maples, are much less than the average value for black maple. So we can see very immediately, we can see a lot of information from this kind of chart. And you'll see that over here as well. This kind of focuses on it. Anybody got any idea what that red dot is? Outlier. Outlier, exactly. When we do this in SPSS, SPSS defines an outlier as any value that's more than 1.5 values for the upper quartile away or lower quartile away from the this chart. In other words, it uses a numerical estimate of what to call an outlier. You really, as a statistician, are going to make your own judgment about whether that's really an outlier and whether you should eliminate that and not consider that as part of your sample. Okay, I'll give you an example. Let's say when you graduate, I ask you all to tell me your salaries, right? So this, and I add it up and I find the average, right? And I find out, okay, there's one person in the class that signed a contract with the Knicks and is making $5 million a year, right? So now all of a sudden the average salary in this class is $1 million a year, right? Not very meaningful, right? Exactly. So if you use the mean, that outlier is very sensitive to, the mean is very sensitive to outliers. So if you're interested in getting a good idea where the middle of this group is, if there's an outlier including it can really throw the mean off. It's not going to throw the median off very much, right? Because the middle person is still going to be pretty close to the middle person. Median, less affected by outliers than the mean is. Okay, so that's one of the things that we might be able to see here when we plot this. If there's an outlier, something that's dramatically different than the other values, then will be easy. It'll be easy for us to spot. One of the other ways we might be displaying data is when we're displaying numerical values that have, for instance, if we're comparing a husband's age and a wife's age. Here's the husband's age. Here's the wife's age. Okay. Well, there's an association between a husband's age and the wife's age, right? They're usually probably the same age when they meet, and so on and so forth, around the same age when they meet. And so, in general, husbands that are younger are going to have wives that are younger. So this will go up here, and there's a lot of this variability, but there's some association. We're going to talk about that later on when we talk about correlation and regression. Okay. Each one of these dots represents a husband and a wife. This is on this axis is the husband's age. So this particular one, husband's age is about 50, and the wife's age is about 62 for that particular person. Okay, so in other words, it's just a linear scatter plot, right? Each one of these represents an X and Y value for the husband's age and the wife's age. Right? So we're going to be taking advantage of that as well, because these scatter plots like this are good ways to see if there's an association between two numerical variables. Okay. You know, I usually show a little video here. When I get through this, I'll break out those little videos so you can get a chance to see them. Okay, we're going to try some hands-on practice with Excel and with SPSS. We're not going to try hands-on practice with R. You're on your own on that. But we might have a chance to have a little bit of fun with that at some point. Okay, so let me go into some of these exercises. I'm going to have to sit down for this. I'm going to have to type and play with stuff. Just so you guys don't faint or die of boredom here, I'm going to take a break about halfway through, okay? But we're not there yet. Okay, and again, these, you can follow along with me. If you go to Blackboard, you can download the various files that I'm going to be using to work on here. In my experience, the best way to handle this is to, when you go to it, if you see me using a particular file, an Excel file, an SPSS file, best thing to do is to right-click on it on a Mac, to option click on it, and tell it to save as and save it to the desktop. Okay, if you save it to the desktop here, at midnight, these turn into pumpkins and they reset themselves, and all the data is washed off of them. That's how they prevent them from having really obnoxious viruses, right? But if you're at home, obviously you can save it to folders or whatever. But while you're here, you might want to consider downloading the files as I use them, and then the two of us can actually work on this stuff together. It's like riding bicycle. You know, if you want to learn how to ride a bicycle, you can watch only so many YouTube videos. It helps to get on a bicycle every once in a while. Okay, so let me get to some of this stuff. There's a lot more stuff visible on my version of Blackboard than is on yours, but there's a reason for that. We'll be making that available as we move forward. I don't want to scare you yet. If I showed you that now, you'd all get scared. How many of you guys are concerned about this course because it's a math course? Okay, it's not really, you know, you're going to find that it's not really a math course. It's a little bit of a computer course. It's a little bit of a epi course. It's a lot of things. It's less of a math course than you guys are going to think it is. And the math that's mostly involved here, I know that one of the requirements they put is that you have like some sort of advanced math, like calculus or something like that. I have no idea why they would be at all interested in you having calculus. Yeah, for elementary statistics, you don't need calculus. Trust me, right? The most you're going to need is math, a good calculator, and some math. You know, some at least a little bit of comfort. You probably, if you've ever worked behind a cash register at a restaurant, you're better prepared for statistics than you are if you took calculus as an undergraduate. Okay, so all right, so let me get to the lab section of this, and there's a bunch of videos in there. I'm going to hold them off for a little while. Okay, let's see, lab. Okay, so here's lab session 1. You should see the same thing I'm seeing. This PDF file here, lab session 1, is what we just saw. Okay, so I'm going to open up this first number 1, the file number 1 for called Cell and Function Demo for Excel. For you guys that haven't had too much exposure to Excel or spreadsheet programs, let me make it big. It's file number. If you look on Blackboard, yeah, hang on a second. Let me pull this other detritus out of the way. If you look under Lab Session 1, if you go to the tab says Lab, open up the folder. It says Lab Session 1. Under Lab Exercises, number 1, Cell and Function Demo. Yeah, the third one down. How you got the rest of you guys able to log in? Yeah, have you been here before? Is this your first time taking a class here?
I mean, I've taken classes here. I have, but they had me, but it's not working.
Okay, let me see. You can use mine. I think I can use mine that ID if I remember it.
Your net ID. Say try that. I have the email password. Your net ID.
Yeah, it might be different than your email password, your CUNY first password, and
They're all
different.
They gave me the email they asked for.
Not the email.
Yeah.
You got the upper lower cases right?
You want to see?
Yeah, let me try it. See if I can log on with my ID. Using my
I can get on, I know my net. I've never done out.
You sign in with your email,
Yeah, that's
it's
what
your
I thought.
Hunter email, and then next, and then it's your Blackboard.
Yeah. It's not active.
It's not, yeah,
Unless there's.
it's not your Blackboard password, okay.
So,
Letter sensitive. Mine's not.
I do first capitalized and lower, keep that lower.
then you're probably going to have to go to another ID for Blackboard. You got a different ID for Blackboard.
I think it would be.
And I think the easiest way to get to Blackboard is to open a browser and go BB. Oh, and actually, I think it might come right up.
But you put two U's.
Okay, guys, I'm going to open that. I'm back where I am here. I'm going to open up that first file. And I'm going to make it bigger so you can see it. How's that? You guys can see that, right? Oh, you want to know something? Can somebody turn off the lights back there? They only like to spend $4 a year on the bulb and the projector, I think. So they don't replace it very often. So it gets pretty dim. Okay, so here we go. So now when you use Excel, there are these things. First of all, number one, most of you already know. You actually are navigating around Excel by identifying the little cells, the little blocks in here by their row and column, by the column and row actually. Okay, so for instance, right now I'm in the cell I'm in right now is B4, and the cell I'm in now is C5, and so on. That's how you identify them. Okay, now you can have any of three things in those cells. There are three possible options. One of them is a label, which is just basically a name. January, right? February. Okay, you can type anything you want in there. Okay, the other thing that you can have in here is you can have a number, 100. You can have decimal, 100.678, and so on and so forth. You can have or an integer. You can have a set 4 or 7 or whatever. You can have a number in there. You're going to see as we go forward that there are ways to format this information so that, a date, you can put a date in there. It's a form of a number, but you can have it display as a date. In fact, when you put a date in here, it's really a number that starts from, I think, I don't remember exactly. It used to be a problem because Macs and PCs used to use a start date that was different. Like I think Macs were like September 2nd, 1914, and PCs used December 3rd, 1926 or something like that. And what they do is they count. That's date 0 and that's date 365. So you actually, it's actually what's really in the background is a number like 32,794 from that date, right? So that's really what's behind there. But you could display it as a date, use it as a date, but it's really a number. So really, you have a number in that cell. The last thing you can have in there is and this is what really makes it powerful, is a function. And a function is some sort of mathematical operation. Like for instance, in here, I can say, I want in this cell, I want 2 times that number 100. So I can put in 100 and put in an asterisk and put in a 2, and it'll do that calculation for me. Another way I could do this, I could put in an equal sign. I could tell it, put in what's in that cell, C4, right? And multiply it by 2 and get the same answer, right? So that's a reference. You use that cell as a reference. If I want to do that a little bit more simply, I can type in equal. I can just click and point at that cell with the 100 in it. It puts the C4 in there for me. And then let's say now I want to multiply it by something in a different cell like this 100.678. And I can do that and it'll calculate it for me. So I can do those kinds of things. One of the most powerful things about this is if I make a mistake and this number was really 99, I can go in there and it will correct that for me. Notice it didn't correct the first one. Why didn't it correct the first one? Because I didn't use a reference there. I put in 100 times 2, right? So it'll actually go there and correct. Now, imagine you're designing an airplane wing and it's based on thousands of calculations that you've done and data that you've collected and so on and so forth. And you find out that on Tuesday at 3 o'clock, your pressure sensor was not operating correctly and you're off by 10%. Now you could go back and change those numbers and do all the calculations all the way through without having to start from scratch. Okay, so here you got another thing you can do here is I'm going to do, like for instance, you might have a ledger with a number of units that you're buying, like at any store like Home Depot, and buying 10 of these at $11.20 each. So the subtotal is going to be equal to this times the value of the individual unit, $11.20. Okay, oops, what did I do wrong? I made a mistake. Let me hit escape. Equals, I got ahead of myself there. 10 times 11.2. Yeah. What did I do? What did I do? Oh, there's a space in front of there. That's what happened, I think. Oh yeah, there's a little thing hanging off the back there. I thought that was dirt on my screen. I don't clean my screen that much. Okay, so at any rate, don't laugh. I use a monitor. These things have you can actually plug into the display thing here and connect the monitor. So usually this thing's closed. I'm using the monitor, so and you get grease on here, so it gets onto the screen. I don't clean it very much. So if you see me occasionally trying to figure out whether that's, type or dirt, that's usually dirt. Because at any rate, so now I might want to repeat that going down this entire row. One of the ways that you can use Excel is that you can take the information that's in this top cell, the calculations in the top cell, and copy it down. I'm going to stop from the first one, highlight them all, copy it down, and go up here to Edit and choose the command Fill, okay, down. It's a little slow, right? And there is, oh, you want to know something? I left one of them out there. Here, let me get rid of that. What am I doing here? Oh, I see. Okay, hang on. No, actually, I didn't get that wrong. Yeah, I had it right, didn't I? Now, but that's okay. Now I can do this another way. I can show you another way I can do this as well. So let me go back to where I was. Except this time I'm going to click in the first one, drag down, right? Except this time, instead of dragging from there, I'm going to go over to the corner over here, hover, and you may notice, if it works for me, come on, I can grab that little corner and I can drag it down, and when I release, why is it not cooperating with me? Well, it should. So let me, I can't believe it's not doing that. Hang on a second. Let me close this and open it again. I might have done something funky here while I was doing the other stuff and messed it up. No, it should work. I mean, I was just doing the same thing. I do it all the time. This times this. Okay, now click in there. Isn't that weird? Up, up, up. I think there it is. I think it's going to do it now. And it did the calculation for me. If you drag from that corner, that little corner there, it'll let you repeat the calculation. So that's a relative, what's happening there, if I click in here, what it's doing is, in the first cell, it's saying that's F3 times G3. But then it sees that you have two columns right beside each other, so it figures out, well, if he's copying it down like that, he probably wants to do that calculation for each row. So the next one is F4 times G4, and the next one is F5 times G5, and so on and so forth. Okay, now Excel has a number of built-in calculations, hundreds of built-in calculators, including dozens and dozens of statistical calculators. So for instance, if I want to add up all these rows, one way I could do is put in this equal sign here, click into each one of them, put plus sign, click into the next, and so on and so forth. Or I can use the logical operator sum, right? And you'll notice that as I type in here, it comes up with a list of different operators that start with different functions that start with S. I happen to know that the one I want is sum. I can put in parentheses, and now I can tell it I want to find the sum of from this column down to this column, and it'll fill it in for me as I drag through it. Okay, and I'll hit enter. Okay, so now for you guys that know Excel, I may be able to show you something now maybe that you don't know. If you really know Excel well, you know this already, but maybe you don't. Actually, I'm gonna save it. I'm gonna save it for, it's gonna be in one of the next versions of this. So that's basically Excel. That's really what you do when you use Excel. Okay. I know this is kind of a simple introduction, but I want to make sure that those of us that maybe have never seen this before. By the way, you may notice as we go forward that I may present some stuff. Now this is PH750. is the less strenuous version of fundamentals of biostatistics. There's another course called PH751 that's called Introduction to Biostatistics. It's really basically the same material. 751 is usually presented in a little bit more challenging manner, right? Now you can use both of them as prerequisites for the next course, but usually for the most part, people that they kind of steer into 751 are ones that they expect are going to be taking other statistic courses, 750, 770, whatever they are. It's more advanced statistics courses, where 750, perhaps you'll be taking epi courses and stuff like that. Maybe you won't be taking another statistics course, right? So it's a little bit more advanced, but a lot of people wind up in this course because they need the credits now to take as a prerequisite for something they're going to take in the fall or something like that. So I'm not going to ask you to do more than that's demanded of you for this course, 750, but on occasion I may add on something that's optional that you can do on your own, right? So for you guys that are looking for something a little bit more challenging, you can give that a try as well. But don't feel you have to do that, right? Or that I'm going to monitor it or something like that. It's just there so that, like, I don't. If you're here, if you're stuck in this course because it's material you already know, but you really need the prerequisite, at least maybe it will make it a little bit more interesting. Okay, so I'm going to open up, surprise, surprise, number 2. Okay, and this is a little bit more, another look at this. And this is kind of demonstrating the what if kind of thing that Excel is very good at. Okay. Yeah, budget demo. Yes, number 2, budget demo. So I'm going to do what I did before, sum of all of my debits, all of my expenses. Okay, and I'm going to calculate all of my monthly credits. And okay, and I'm going to do that. And I can see that my balance is going to be equal to my credits minus my expenses. So I'm in the hole, $340 a month. Well, now I got to go back here and say, yeah, entertainment, I'll go out to the disco a little less often. Are there discos anymore? I'm dating myself, right? Okay. Let's see. And rent, I get another roommate. We have 7 roommates. Obviously, I must have 7 roommates already if I rent $500. So I'll get an 8th. Maybe it'll be 400. And you can do a kind of what if. See how that sum, that the overall balance is adjusting itself. Oh yeah, good idea. Formulas. Okay, for balance, the formula is just E7 minus B10, right? That's, in other words, that 1400. I'm sorry.
Our total debit is 1740.
Oh, I've been changing them. Yeah, see, so for instance, like here, like entertainment, if I want, see, right now I'm still $40 short, $30 in the red, and actually you can format this even so that that row or column, if it's a negative number, displays in red. So you can go into you can go into Excel, go into Format, Cells. I don't know why it's not. Oh, I know why, because I'm still in the equal sign. Format Cells, right? And you can go in there and tell it that it's a number, but I want I want negative numbers to display as red. There you go. So it's $40 is in red. Okay. So I go back in here and I say, okay, if I I'm sorry. I'm not. I'm rushing through this a little bit because I don't want to bore too many people with it. Who know this. I'm going to go here. I'm in this cell. I go up to Format, Cells. Okay, and you can highlight more than one cell if you want to reformat it, or you can highlight a whole column if you want, right, and reformat that. And I can go into click under number. And there's different kinds of formats. If I want 1 decimal place, I can tell that I only want 1 decimal place, but we're dealing with money, so I'll do that. If I want to show negative numbers with a parentheses in red, I can choose that particular choice. Okay, and there it is. It's shown as a parentheses and in red. And now if I go back and say, oh, tuition's free now and so on, and I eliminate that $300 expense. Well, now I'm in the black, and I can go and party a little bit more each month. You can order a pizza, right? So that's one of the strengths of Excel. It's very good at organizing data, doing calculations. It's very flexible. Now I'm gonna move on to using this kind of thing for statistical analysis pretty quickly here. Let me see what I got next. Oh, graph demo. The next thing I want to show you is you can also use it to help you display data. Okay, and I want to blow this up a little bit so we can see it. Okay, so here, I've got data that's organized into two columns. One is location, that's the title of that column, and mold spore counts, right? If you do any environmental work, one of the things you might do is take mold spore counts from the air to determine whether there's an issue in a location or something like that. And I took it in different spots, a couple of outdoor samples, a couple by the receptionist, a couple in finance, and so on and so forth. Now, perhaps this is kind of hard to interpret. It'd be nicer if I could see this as a bar chart. So I'm going to click here and highlight all of these. Now, notice the format here is very specific. It's columns, and the top two things are the top row is the label for that column. Okay, so I'm going to go over here to charts. And I'm going to tell it I want a column chart. It calls the bar charts, vertical charts, column charts. I'm going to choose clustered bar charts. And here we go. It created almost instantly a very readable chart for me. Okay, that's a bar chart because, right, there are different areas, right? It's not one leading into another. Okay, so we can see that the outdoor level is much higher than the indoor levels.
You're doing this on an Apple, so I think we're getting a little.
Oh.
Yeah, that's.
Yeah.
Oh, yeah?
File, home, and serve page layout formulas data. We don't have format
Oh, yeah?
or tools. We don't have that at the top.
Oh, well, hey guys, you know what, yeah, you have a much newer version. You know what it is also? If you look carefully, there are going to be, I'm going to go back here to home. You're also going to have within these, what do they call them again? Not strips, ribbons. Within this ribbon at the top, you'll have various ways to format stuff. So you can actually find the same things that I did with the drop menus are buried in these ribbons. I'll see if I can't find something online that's got something that demonstrates some of this stuff with a newer version. Trust me, we're getting a little bit off on a tangent here. I'm never going to give you a hard time about how you format your data. However, as we get towards the end of the semester, we may get, at the end of the semester, I'm going to give you guys a choice of either taking a third exam. They're all non-cumulative, by the way. Taking a third exam or doing a presentation. And the presentation will be you analyzing some data, either a data set that I'll rustle up from somewhere online like New York City Department of Health, or some data of your own that you might have access to, and presenting it in the form of a poster. Anybody ever been to a poster presentation? Seen poster presentations? Yeah. What happens is if you go to a big conference, the American Public Health Association, once a year has a big conference, usually in Washington. There's a lot of speakers that present their research at these things. There might be a dozen rooms simultaneously with researchers presenting their work, their conclusions, and so on and so forth, their statistics. But unfortunately, there are hundreds, maybe thousands of researchers that are also working on interesting things that are not going to have the opportunity to present to everybody in a big auditorium. So what they do is they do poster sessions. And the poster sessions are basically, remember you and kid, you did a science fair, and you had a big OTAG thing, and the OTAG, they don't make OTAG anymore, foam core nowadays, right? Right. So you had a big foam core thing, and you put your stuff on it. Well, they would have professionally printed material put on foam core, so they could put it on an easel or on a wall or on these various rows where they have these separators. And you could have hundreds of people, hundreds of researchers, where they have these large posters that show what the name of their study was, how they collected their data, graphs on their findings, conclusions, and so on and so forth. And you literally, what you would do is you'd walk up aisles of these, in other words, and then turn around, come back down the other side like a craft fair, right? And go back around and stuff like that. And you would walk through aisles of these things, and as you glanced up at it, you might find some research that you're interested in. Maybe you're interested in Legionnaire's disease, and 2 or 3 people have posters where they've done research on Legionnaire's disease. As you walk through, there's one there. You might stop, take a closer look at that one. The researcher might be standing next to it. You can ask them questions, discuss it with them, and then continue around. I'll show you pictures. When we get to the end of the semester, I'll show you pictures of what these posters look like. Well, one of the options you would have, instead of taking a third exam, is to make up a smaller version of that. It might only be 7, 8.5 by 11 pages, printed big, so that we could read it and stuff, and then present that to the class. Get 5 minutes and present your analysis of the data. What tests you use, what the demographics were, what your descriptive statistics were, maybe a couple of charts on this. So in that case, the formatting and stuff might be of some interest to us. So, but we got plenty of time to learn that. So don't get too stuck on this right now, especially since we might all be using slightly different versions of this. By the way, IBM is much slower at doing significant updates. So, and in fact, they're not very creative. So SPSS looks virtually identical on every computer, right? So even like you go back 10 years, it's completely recognizable. Works basically, as far as we're concerned, will work basically the same way. Okay. So let me open the next one up here, which is number. Oops, I clicked on it too soon. Where was I? I was at number 6. Well, number 5 is age adjustment. Yeah, did I do 4? No, I didn't do 4. Okay, let's open up number 4. That when you put these things on here, it's hard to get Blackboard to be very cooperative in terms of like sorting these things. The attachments it doesn't understand sort attachments by name. So you kind of got to manipulate it a little bit. Doesn't work all that well. Okay, so I am going to now use some of the statistical functions that are built into SPSS. Okay, for instance, first thing I'm going to do is I'm going to calculate the mean. I'm going to go through this quickly because we're going to do it again after we take the break. Okay, a little bit more detail. So how do we calculate the mean? Well, there is no function called mean. See, nothing comes up there, right? There is a function called average, which is basically the numerical mean. So I'm going to tell it to find the average for these 10 numbers, and it will calculate it for me. Now, median, there is a function for median. Okay, well, how do I know which functions exist here? And I'm going to do the same thing. I'll highlight all of these, and it'll calculate the median for me. Median's a little bit smaller than the mean is. What's the mode? Anybody know what the mode is? Right, the most common result, right? The number that comes up most frequently, right? In a histogram, it would be the highest bars, right? So the mode is going to be, let me see what the mode is. I think I see it already. Mode is 80, right? You can see there's 1, 2, 3 80s here. Okay, so what's the minimum? Well, there's a function called minimum, right? Min, you just use min, and it'll give us the minimum value. Okay, and we'll go to the function called max, right? For the maximum value. Okay, and now that I know the minimum and maximum, I can just use this cell to calculate the difference between the maximum minus the minimum and get what's called the range. Okay, so there are functions that have specific uses. If you're a realtor, there's specific functions in here for realtors. If you're in finance, there's specific functions in here for stock pricing and stock calculations, interest calculations, every kind of area of study, engineering calculations. There's trigonometric calculations, right? If you want to know what's in here, somewhere, depending on your version, you'll see a little thing that says f of x, function of x, or function. If you click on that, it'll bring up a window that will allow you to scroll through all of the different functions that are here. There's a search function on here too, so you can try and narrow it down. You can also tell it that you only want to see statistical functions, you only want to see engineering functions, and so on and so forth. I'll leave that up to you guys to kind of explore a bit. The range, I just did the calculation. I just subtracted the value for the maximum from the minimum from the maximum, and that gave me the range was 25. No, I did it on here. See it down there?
Yeah, what did you type in?
Here. Whoops.
You did it manually.
I'll do it again. I'll do it. I'll do it up here, as a matter of fact. Okay. Equals, right? And I'm going to click on the cell where the maximum is, A18, minus the cell where the minimum is, A17, and that's my range. Okay, no function for range, so I just was creative.
The range is maximum minus the minimum.
Yeah, exactly. It's just like, in other words, if the youngest person is 10 and the oldest person is 70, the range is 60 years. Okay, just happens to be another statistical function, another descriptive. By the way, a lot of the things I'm talking about here are what we call descriptive statistics. They describe the nature of a population. Okay, so I'm going to close this now, and I'm going to open up the, let's see, 7, okay, 6. Oops, I keep clicking on this stuff. It opens too quick for me. Yeah, no, I'm not going to do that yet. Not going to get to that yet. I'm going to do an exercise that involves calculating the most important descriptive statistics that we're going to be using. And we'll give you an understanding of where they come from. I could very easily, in this previous selection, the one I'm using now is in the second group. It's called Descriptive Statistics Exercise 1 Excel-1. I don't know why that part came up. Descriptive Statistics Exercise 1 Excel-1. Okay, so that's what's here. I just laid this out so we wouldn't have to kill a lot of time redoing this stuff. I'm going to make this a bit bigger. I always hate the fact that these screens are so low here that you lose, if they were thinking, well, you know what it is, they had the projector up there. I guess they couldn't put it up any higher. But that's why it's nice to be able to follow this on your computers also. Okay, so I'm going to go through, I'm going to go through this, and then we're going to take a break. Let me stop for just 1 second. How many of you guys feel I'm going too slow, that this is too simple? Nobody feels it's too simple? How many feel I'm going too fast? Okay, so I'm just right. Okay, it's like, like the Three Bears, right? I mean, what do you call it, right? Exactly. Too hard, too. Okay, so far we're in a good range here, right? Okay, so now I'm going to actually use Excel to do some actual statistics, but I'm not going to take advantage of the built-in functions because I want you to understand where these terms come from. When we looked at statistics and the different forms of them, one of the things that we saw in that side-by-side thing with populations and sample was the idea of mean, right? The mean, the median. There was something there called standard deviation. There's something there called variance, and so on and so forth. So we're going to go and examine where a lot of these terms come from, that as we go forward in statistics, they're going to be important to us. If I take a sample, I'm going to randomly sample some population. I'm randomly sampling it because I want to know about that population. I don't want to know about the 20 people I picked, the 100 people I picked. I want to know, where's the middle of this population? What's the average blood pressure of this population? What's the average? What's the prevalence of diabetes in this population? I want to know about the population. Unfortunately, I don't have the resources usually to test an entire population, but I might have the resources to randomly pick people in this population, analyze that sample that I've taken, and then generalize it to the population and say, well, the average blood pressure in this population, in this sample, is 110. Okay, it's a pretty big sample, 100 people, right? So I can generalize that and say, I think that's a good estimate of the population blood pressure. That's what we're doing with samples. There's 2 things I'm usually interested with a sample or even with a population. One is, where's the middle? What's the average? Is the average blood pressure for Americans different than the average blood pressure for Canadians? Is the average American cholesterol level same as the average total cholesterol for Frenchmen, right? Is the average BMI for American males between 27 and 34 higher than or lower than the same number for Germans, right? I want to know where the middle is. I want to see if I can compare the middles of those populations. How are those averages compare with each other? So the middle is one of the things I'm interested in. The other thing I'm interested in is, how variable are the numbers in these populations? If I went to Germany, is the cholesterol level all within a certain range, very tight range, because they're all eating bratwurst, so they all have cholesterol levels between 300 and 400, right? Or in America, is the variability of the cholesterol much wider? Some people have 50, some people have 500. I want to know the variability, and I want to know where the middle is. So there's two things I'm interested in. Okay, so let's take a look at this list of numbers. First of all, one of my problems with this list of numbers is looking at it this way, it's not very organized. I can't really see the middle easily. So I'm going to actually use the mean to calculate the mean in order to decide what the middle of this sample is. So I'm going to go down here. I'm going to calculate it in here. Equals average. Remember, there was no actual mean. It's average in this case. And I'm going to identify the cells I'm interested in. It's going to be A2 through A19. Okay, so the average is pretty close to 100, 99.94. You know, I'm going to take advantages. I'm going to click in here, and I'm going to go up to my format. You can find this on your own where it happens to be. And I'm going to say for this whole column, make this number only one decimal place. Okay, so it's going to be 99.9. It's going to, now, in that cell is still that original number with all those decimal places. You don't lose that when you change the format. And if you do a calculation based on it, it will use the real number, not the rounded number. Okay, good thing. That's a good thing. Makes it simple to read, but still you don't lose the accuracy. So that's the mean. Well, one of the ways that I could calculate the mean, how about the count? How many values are there? How many people do we have in our sample? There's actually a function called count, C-O-N-T, parentheses, and I'm going to go tell it, okay, between A2 and A19, and there happen to be 18 people in our sample. Okay, happens to be another function that's in Excel. Okay, so now I'm going to go in here and I'm going to say to myself, you know, I want to calculate how am I going to describe the variability. I know where the average is, the arithmetic average is. It's 99.9. How am I going to describe how spread out this, what the variability is? Well, one way I could do this, I wasn't planning on doing this, but one way I could do this, I'm going to copy this. I highlighted, hit Control C, and go over here. I'm going to do a Control V, right? And then I can go up here. Again, it could vary where you're going to see it, up to data, and say sort. Actually, I think there's a ribbon. There's something on the ribbon here where you can actually tell it to do that. I think it's scrolled off on the other end of my ribbon, so I'm not going to go searching for it. I can say sort. It's like an A to Z. You'll see with A to Z, and you can just click on that. And I'm going to say sort, smallest to largest, and it's sorted them for me. So I can see the smallest value is 88, the biggest value is 114. I could have also used the commands, the function minimum and maximum to do that also. However, I see, doing that, sorting it, finding the range, that's pretty interesting, but it really just tells us what the lowest and what the highest is, really doesn't tell us how well grouped it is. It's mostly in the middle and the end. It really doesn't tell us that much about the real variability here, right? So what I want to calculate what the variability is. I mean, we could have one person that's 88 and then everybody else is real high, right? Doesn't really tell us that much about the real variability in this entire sample that we have here. So one of the ways I'm thinking that I might be able to do that is to take 99.9 and find the difference between every value and the mean, right? So the reasoning here would be if there's a lot of variability, there'd be a lot of difference between the mean and each individual value. So I'm gonna in this second column, I'm gonna put the mean. That's going to be equal to the mean, 99.9. There it is up there. So now I want to copy this down. Okay, I'm going to grab that in there. Oh, geez, I'm not going to. I don't know why it's giving me such a hard time here. I think I got it that time. Not sure, but no, it didn't do it. Undo. Boy, it's weird that it's giving me such a hard time. Yeah, it did it down. You can double click that little dot, does the same thing. Well, what happened here? Well, 99.9 is let's see, that's B71, B21, right, which is the mean, that's right. The next one's, B22, B20, what happened here? Remember that thing where it'll do that? It'll automatically go down because it sees the columns alongside of each other and it will automatically reference the next cell? Well, it did that. It wouldn't let me copy it down, right? So what we can do instead is instead of putting in this cell here, instead of putting B21, I'm going to put a dollar sign, which is actually what the value in that the mean is that I calculated. I'm going to put a dollar sign in front of the B, and I'm going to put a dollar sign in front of the 21. I hit it enter. It's the same number. Nothing's changed, right? But I just put the dollar sign in front. It's oops. Hang on a second. If I click in there, you see the dollar sign there. Dollar B, $21. I just stuck a dollar sign in front of the column and the number, right? So all it's doing is echoing what's in B21, which is 99.9, right? So now I'm going to copy that down now. Okay, I can do it by clicking it. This time it worked. Why did it work? Because I told it that the value that's in there should not change. That's called absolute addressing. When you don't put the dollar sign in there, it's called relative addressing. So Excel will adjust it row by row by row by row, thinking it's helping you. Okay, so if you put the dollar sign, if you want to be able to use that same number in other places by dragging it or something like that, repeat that number over and over again. But it's a reference to another cell, and if you drag it down, it's gonna change that reference. You don't put the dollar signs in there. That's relative addressing. Now it's absolute addressing. So now when I copy it down, it'll copy down the same, an echo of the same cell in every one of these things, right? An exact mirror of that cell. Okay. Now that's something that if you use Excel a lot, you probably didn't know how to use, right? So we've learned. Everybody here has learned one thing about Excel they didn't know before. I guarantee that. Most people don't know that. Okay, so now let's take a look at the difference between each individual value and the mean. So I'm calling the mean X bar. So the difference between each value and the mean is going to be X minus X bar equals 99 minus 99.9. Okay, and that one I'm going to copy all the way down as well. Okay, I'm just going to drag it down, copy every one of those. And you'll notice that this one is off by, it's lower by 11.9. This one is higher by 14.1. So now in order to get an idea of what the total variability is, how variable everything is, I'm going to add up all these differences. A lot of variability, I should wind up with a big number. Very little variability, it should be a little. If everything's close to the mean, it'll wind up at the sum is a little number. So I'm going to go down here, equals sum.
I get 0.9 for everything.
Hey, there you go. Okay. Yeah, exactly. Why did that happen? Because it's the mean. That's what the mean does. Half the values are above, half the values are below. Right. That half the values are above. I got 0 because I didn't copy the number. I actually used the original number, which was, remember I reformatted it so that it was only one decimal place, but I didn't bother to type it in as 99.9. I'm referencing the original number. Don't worry about it. You can go back over the video and you can take a look at what I did there. Okay, so that's no good. I can't just add them together. Okay, now if I want to show the variability as the differences between each value and the mean, what do I need to do instead? I can't just add them together because the negative numbers, there's half of them are lower and half of them are higher. That's the nature of the mean, right? What can I do instead? Well, one thing I can do is I can say to myself, use the absolute value. Right? Well, in our case, in statistics, turns out we really don't do that. They do something a little bit different. They say, let's take each number and square it. If you take a negative number times a negative number, you multiply a negative number itself, becomes a positive number. Positive number is positive, so everything's going to be positive. So I'm going to take each one of these numbers times itself. Okay, that's going to turn out to be a plus 0.89 as where it used to be a minus 0.9. And now I'm going to drag down and copy them all the way down. So all of these numbers are now positive numbers. They're inflated numbers, but they're all positive. So now I can add them all together. Sum.
Yeah.
I'm sorry, did I miss something there?
What formula did you use?
Okay, hang on a second. I'll go back.
You just multiplied it.
I just said C2 times C2.
Okay,
That
that's
looks
it.
like you did C2 times 2.
Can you see that? I can't
You
expand.
didn't do it, but what it looked
Oh, what it looked like? Yeah. Oh, okay.
C2 times 2.
No, it's actually, it should be C2 times C2. Okay? And then if I go into the next cell, it's C3 times C3, C4 times C4. That's why filling down or copying down that formula is a good thing in this case. Notice I didn't use the dollar sign because I didn't want to carry down that first number. I wanted to actually do the side-by-side calculation. Okay.
Carrot two?
What's that? Caret is a power. Yes,
Oh,
you could do that.
That's why.
Right,
that's why
exactly.
I asked.
C2 caret 2
Yeah.
would be C squared.
It's the
It says shift.
the shift of the number 6 cube.
Yeah, shift 6.
Yeah.
Okay, you could do that also. Okay, so now I'm going to add these all together. Okay, take sum and add all of these together, all of these squares together. Oops, what did I do here? Boy, did I mess this up. Hang on a sec. I didn't put an equal sign. That's what happened there. Hey. Okay. Equals sum, parentheses, and now I'm going to go over it and tell it. I'll type it in here. What is it? A2 colon A19. Oh, no, I'm sorry, not A. D2 colon D19. You can actually type in these ranges if you want. Just put a colon between the first one and the last one. And that's the total, right? 894. Let's give that a name, right? What did we just do there? We took the differences, we squared them, and we found the sum. Why don't we call that the sum of the squares of the differences, right? That's what it's called, believe it or not. It's that simple. This is the sum of the squares of the differences between the mean, and I'm adding this part, between the means and each individual value. That's an important first step in determining the variability the way we use it in statistics. Now, I'm going to take, there's a problem with that. The problem with that is now this number is enormous because we squared all these differences. Now let's go back and, well, first of all, we have two problems. One is we really don't have the average difference. We have all of the differences added together, right? So I'm going to divide by the count, by 18. There's 18 values here. I'm going to divide by 18. Now you're going to see me do something a little weird here. Instead of dividing by 18, I'm going to divide by 17. I'm going to divide by the count minus 1, n minus 1. Later on, we're going to talk about reasons why I'm doing that. So I'm going to take 892, the sum of the squares of the differences, divide it by basically the count minus 1, or 17. Whoops, 17. I'm going to enter. So now that's basically the average of the sum, the average value for the squares of the differences, right? That's basically what that is. It's an average value for all of those squared differences, right? I used 17 instead of 18. I cheated a little bit, but that's really basically what it is. That number is called the variance. We're going to be using that all semester, that term, the variance. Okay? Now, the next number, I'm going to do, what other correction can I make to bring this back into reality? Well, I squared these things. So now, in order to bring this number back into the realm of the order of magnitude of all the rest of the numbers that we were working with, I'm going to find the square root of that number I just calculated, the variance. So equals, and there's a function in here, SQRT, parentheses, square root. SQRT equals SQRT. I'm going to click into or type in D21, which is the variance, hit enter, and that now is called the standard deviation. I know it's low down. So how about that? I'll lift it up a little bit. That's now called the standard deviation. This is the only, yes. Sure. I'll do this one again. I'm gonna equals the square root, SQRT, parentheses, and I'm gonna put in D20. I can either type in D21, which is the cell where the variance is, or just click into it, have it fill it for me, hit enter, and it's 7.24. So the mean of this sample is 99.9. The standard deviation of this sample is 7.25. One of them is a measure of the middle of this population. The other is a measure of the variability called standard deviation. Okay, these are standard terms we're going to be using going forward. Okay, are we ever going to do this again? No, we're never going to do this again because we're going to use here. Instead of doing that, why would I do this when I can just simply say equals STDEV, parentheses, standard deviation, just highlight these 18 numbers and get the same answer. Yeah, equals STDEV parentheses, and then highlight all of these. Just put in A2 through A19, A2 through A19. Hit enter and get the same number. Right? I'm sorry. DE equals STDEV parentheses. You know, sometimes what's going to happen is as you type in these terms, you'll see it'll highlight, it'll come up and guide you a little bit, and you'll see equals STDEV. It'll start to narrow down your search, but then even then at the end you'll see STDEV dot something and dot something else and dot something else. Don't worry about those. Those are just more modern versions of the same calculation. You can just stop right there, STDEV for almost all of these, use parentheses, put in the range, and hit enter. Okay, so why would I calculate when I can do average and just, equals average equals STDEV? Why would I bother doing all this? And the reason why years ago, I would do this and just show you how to calculate it on Excel and SPSS using the functions. But then students would leave here and they wouldn't know where that term standard deviation or variance came from. You now know where those terms came from. You don't necessarily have to calculate them this way ever again, right? But now at least you understand that they're not pulled out of the air, they're not invented numbers, right? They're actually you could have almost sat down here on your own and said to yourself, if I was going to invent a way to describe the middle and the variability of this sample, this is the way I might do it, right? So you can almost invent this part of statistics yourself if you sat down and kind of really thought about it. Okay, so I'm going to take a break at this stage. Okay, so we'll rest our minds a little bit. We'll relax. I'll go put some money in the meter and be right back.
We're ending today at 7:30. 7:05.
7:50. It's either 5:05 to 7:50 or 5:30 to 8:30. When we come back, we're going to discuss when this class is going to be. Okay, whether we're going to go with 5:05 or I think I may have to go with 5:30 because if they put that in the schedule, they may have. No, is it in? You talking about the syllabus or the schedule? The syllabus I made, right? Yeah. We're going to talk about which one we want. And between me and you, the earlier one. Yeah, I agree with you. And to tell you the truth, since I'm recording this, if people wander in a little bit late because they can't get here too early, from work or something like that, that's okay with me. And I don't have a problem with it.
So all the formulas you went through are going to be saved on Blackboard for us, and we can.
Oh, you'll be able to see exactly what I did.
Yeah, no. Those will be empty templates, and then when we go through your URL, we can play around and go back.
Yes, you can actually play the video.
I kind of picked up in the beginning, so.
Yeah, you can actually play the video.
So this will play on a YouTube video.
Everything you saw, my voice and everything you saw behind me will be on YouTube. Yes.